Hey everyone, welcome to this video. In this one, I'm going to talk about a problem which is on Leetcode. It is of medium type complexity problem, and the problem is add two numbers. The numbers are in the form of linked lists. So you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Examples are provided. So here both list nodes are of same length 2, 4, 3, 5, 6, 4. 5 plus 2 7, 6 plus 4 10, and 1 is carry, which is added to the next sum, which is 4 plus 3 plus 1, carry from the previous summing. So yeah, so that's the result 708. Now for a problem where the length of list nodes is not same, it is similar to any other addition that we would do, other than linked list, like normal mathematical summation. So what's happening here is that some will, these nodes will be added. So 9 plus 9, 18, 8 is the response here, and 1 is carry, which will be added to the next sum operation. So 9 plus 9, 18, and then 1 is carry from the previous sum. So the result is 9, and so on and so forth. And when L2 ends, which is here, so it's all these three nines. And then when you are adding carry to 9, it will become 10. 1 would be carry for the next one. Again 0, 1 would be carry to the next one. And then we are left with a carry. So we will be adding a new node to expand the list beyond the max length of L1 and L2. So that's pretty much what we have to do. Now, how to do it in program? So that's where we'll have to be a little bit creative. So what we are doing is that we are going to have two list node variables. So we're creating this one, and then we are creating another one which stores the reference of res, because when we are going to add, we will be pushing res to res next. So that's why storing the reference of the initial list is important, because in the end what we would do, we would return result dot next. So that is why we need to have two nodes. Let me know in the comments, like, if you have a better solution, which does not need more space. But yeah, right now that's what I can think of. And then we need carry, sum, and we need a couple of more integer variables. And then we are doing a while loop. So what we are saying is that while L1 is not null, or L2 is not null, and within the loop, what are we doing? So we are going to get L1 val as so since we have this or condition, we could be in a situation where L1 is null or L2 is null. So we have to check if L1 is equal to null, then we want L1 val as 0, and if it is not null, then we just want the value of that node. And similarly, we want to do the same thing for L2. So if our list 2 is null, we are going to make L2 val as 0, otherwise L2 dot val. And then what are we doing? So we are going to add L1 val, L2 val plus carry. For the first iteration, carry is 0. So yeah, carry is 0. We are adding L1 val and L2. Then we are going to calculate carry, which is sum divided by 10. And if I think what we can do, rather than writing another if condition, we can just add it like this: new list node, we are checking here if it carry is greater than 0, then that means we need the modulus of sum in the node value. Otherwise we need just the sum without worrying about the modulus. So that's what we are doing. So we are adding a new node to the res.next, and we are going to move res to res.next so that the next addition of the nodes is stored in a new node. And again we have to check if L1 is null. That means we don't want to do L1.next, otherwise we would have null pointer errors. Same thing for L2. If L2 is null, we do not want to land up in a null pointer error. So you're going to check that before we do L2 is equal to L2.next. So this is fine. It will take care of summing up L1 and L2. We have to worry about one more condition though, like if after all the additions, if carry is still greater than 0, that means we have to add a new node to the end of the result list, and the value of that node would be just carry. Now we have already added result.next. Result.next was pointing to the first node of result, and that first node is a dummy node, so we just want to return the next, and the next would be the actual nodes with all the right sum between the value of each nodes. So I think this would work. Fantastic. So our test case passes without any issue. Now we're going to just submit it, and that also works well. So the time complexity of this is just like O of the maximum length between L1 and L2. So you can think of it like ON, and then we also added space. So we created a new linked list. So space complexity is also ON. I think there might be better ways to not at least do the space part of it. I will think about it and add it as a comment later on. But if you think of any better solution where we can save on space or something like that, let me know in the comments. And for this solution, if you have any questions for me, then yeah, please comment and I will get back to you. Thank you very much.